This is the video solution to practice problem A that accompanies sample exercise 1.3 in your textbook. This problem appears on page 13. We're asked to solve a two-part problem given that 25.0 milliliters of mercury has a mass of 340.0 grams. We'll need to calculate the density of mercury and then calculate the mass of 120.0 milliliters of mercury. The main concepts involved in solving this problem involve density. We must understand that density is the ratio of mass to volume. We must also understand that once we know that ratio, the ratio itself can be applied to any sample of the same matter. In other words, density is an intensive property of matter. It won't change if the size of the sample changes. To solve part B, we'll have to use the density that we calculate in part A. We'll begin by looking at the density equation. You can look it up on your exam information sheet if you can't remember it. Density is mass divided by volume. We are given a 25.0 milliliter sample. This is the volume, and we know that the mass of this sample is 340.0 grams. Calculating the density of mercury is pretty straightforward here. We take our mass of 340 grams and divide it by the volume of 25.0 milliliters. The calculator says that the value is 13.6, and we have to record the units on this value as grams per milliliter. None of the units cancel. When we consider significant figures, we see that 340.0 has 4 significant figures and 25.0 has 3 significant figures. So we have to record our final solution to 3 significant figures, or 13.6 grams per milliliter. For the next part of the problem, we need to find the mass of 120.0 milliliters of mercury. We can look at the density equation and rewrite it with mass on one side by itself. Algebraically, we must multiply both sides of the equation by V. This tells us that to solve for mass, we will multiply density times volume. Our volume of 120.0 milliliters and the density that we got in part A are the pertinent values here. Multiplying 13.6 grams per milliliter by 120.0 milliliters will result in a mass. When we clearly show our work, we can see that the units of milliliters occur in the numerator and the denominator of these values and should cancel. This leaves us with a mass of 1,632 grams. We still have to think about significant figures. Our density was recorded in 3 significant figures, and the volume was recorded in 4 significant figures. Our only mathematical operation here was multiplication, so we should round our final value to 3 significant figures. This means that 1632, or 1,632, would round to 1,630 grams. You could also write that in scientific notation, and it would be 1.63 times 10 to the third grams. Let's see if this answer makes logical sense. From part A, we knew that the mass of 25.0 milliliters of mercury. In part B, our sample is 120.0 milliliters of mercury. It's a little less than 5 times the first sample. Our mass then should be a little less than 5 times the mass of the sample in part A, and it comes out to be roughly that value. Our answer makes sense based on the data. Now you should try to solve practice problem B in this group on your own. The problem appears on page 13 of the text, and don't forget to show your work for each part of the problem. You can verify your answer with the values that appear on page 33 of the text.